Hi everyone, we're going to pick up where we left off in our discussion about how geographers use and interpret maps. It's important that you label this set of notes and your corresponding analysis questions very carefully so it's clear that that you have completed both flipped videos relevant to this question. We have flipped video 1.3, part 2, how do geographers use and interpret maps. Last flip video was labeled Map Basics. Now we're going to get into the types of maps that are out there and the process of modern map making. So taking a look here, we're going to begin first with talking about the fact that there are two types of maps. We've got reference maps and we have thematic maps. Both of those red terms in red should be on the left-hand side of your notes. Reference maps are used for identifying geographic features. It makes perfect sense if you consider the root term of reference. You're going to use it for reference to figure out where are the boundaries of Washington, D.C., where is the Anacostia River? Where is the Chesapeake Bay? What are the Potomac River tributaries? Reference maps help us see where something is located simply. Thematic maps, on the other hand, are a type of map that are used to show or to trace a particular theme in a given place. Does this type of um, housing, where is it most prevalently found? What areas are experiencing crime versus another? This one here is an example of a thematic map of housing sales. So we're going to see what types of sales, and this one in particular is showing us the single family median price for the sale of a home in a given place. So it's how much did this particular house cost when it was sold, and that information is then spread out and analyzed over space. Reference maps, kind of where something is. The thematic map is tracing a theme. It's looking at a theme across space. So let's break this down. We're in the reference maps category. So let's go ahead and put on the left-hand side of your notes two things: reference maps, and then underneath that, political maps. So both reference maps and political maps on the left-hand side. So it's clear that a political map is a type of reference map. Political maps are used to show, it's probably what you're most familiar with or what you most associate with a map, is just territorial boundaries, territorial borders. A political map is going to show us where a particular country's borders are, their major cities sometimes, and sometimes their capitals. So it just depends. But the bottom line is the political map is showing territorial borders. We're going to spend a whole unit talking about what these borders mean, why they're shaped the way they are, what the consequences of those borders are they even real? But bottom line is that's what a political map is used for, to refer to for us, so we know the borders of a given place. And similarly, a physical map. A physical map shows us the geography of land types, bodies of water, and land forms. It's going to show us likely label where rivers are, where lakes are, where mountain ranges are, deserts, Arctic regions, tundras. A physical map is often going to show us environmental. Well, I'm not going to go too far into it, but yes, physical map is going to show us here the geography, the land types that we're going to find. That too is a reference map. Here's a physical map of the United States just to give us an example of that. So we see the major rivers, we see the Rocky Mountains, we see the Appalachian Mountains all on the eastern coast. We see the Gulf coastal plain, so the area that's close to sea level by the Gulf of Mexico. We have our Atlantic coastal plain. We have the Sierra Nevada mountains on the on our western territory, I guess, would say the Great Basin. So bottom line, this is showing us the physical land features. In contrast, let's go over to the thematic maps, the second category of maps. And if you're going to show a theme, if you want to show where something is and where something is not, one way to do so is through colors. And a choropleth map shows data or represents a data or a theme by colors. In this particular map, we have GDP per capita. GDP, we're going to use this in class, stands for gross domestic product. Gross domestic product per capita means per person. Gross domestic product means the value of all the goods and services that one country produces in a given year. A really way too boiled down and way too simplistic way to say that would be how much money this place has. That is an insufficient explanation, but to get our minds thinking about economic indicators, the GDP shows us how much the value of all the goods and services in a given place divided by the number of people who live there. That's the per capita. You'll see here that if we're looking at this choropleth map, if you look on the right-hand side, the legend tells us that areas in the darkest blue have a very high GDP. per capita. The areas that are very lightly shaded have very low GDP per capita. It's not an accurate way to simply say rich and poor countries, but this is to get us thinking about how information is displayed over maps. These are more economically strong countries versus ones whose economy is still developing. But again, let's not read too much into that, because we're going to get to much stronger and much more complex economic indicators in the coming weeks, coming months. Another way to show a theme or to show information is what's called graduated symbols, and the symbols change in size to represent data. I thought this one was pretty cool to take a look at, because this is from the National Alliance for Public Charter Schools. I bet from those of you listening to this, if our statistics stand strong, then 1/3 of you, 33% of you, went to a public charter school for either middle school or for elementary school before you came to McKinley. And you see that that this very large circle that's corresponding to Washington, D.C. here is absolutely enormous. One of the only other places in the country that, well, you can see all of the areas of the country that have a similar number of charter schools. The leading number of charters is down there in Louisiana, which was a product of the public schools changing after Katrina. But it's pretty cool to consider that we are, or I guess I should say, depending on your personal political preferences, it's an interesting trend that we have such an enormous number of charters here in DC, and that's represented thematically on this map as a representation that there are more in DC. There's plenty of places on this map where charters are not legal, so there's no data at all. Another way to show a theme is a dot distribution map, and dots represent one of something. So, for example, here this is a slightly outdated map, but it was a clear representation of a dot map. So, you notice in the legend on the bottom right-hand side, this is showing us tobacco agriculture. When we talk about tobacco, we'll see the extent to which tobacco needs a very long growing season, which is why it's primarily grown here in the South. In the tobacco, it says here 1 dot represents 1 million pounds of tobacco grown. So 1 dot is representative of that of 1 million pounds of tobacco. So 1 dot, 1 million pounds. This dot distribution map then sort of would say, well, in this general region, we have this produced as 1 million. So the dot distribution shows us, again, the theme using dots. I want to show you another one here with another kind of demographics one that we're going to take a look at, called the racial dot map, and this one's kind of cool. This is using 2010 census data, and it's looking at race and looking at racial identity and distribution. And you see that the dots here, 1 dot is representative of 1 person. And if you look here down, that you and I live in one of the more diverse regions of the eastern seaboard, which is a good thing. And you can see just sort of across the United States the distribution of and the diversity across the U.S. So another example of a dot distribution map, one that we will actually come back to when we get to our culture unit. Another type of thematic map is called an isoline map. And an isoline map, I'm going to read you the definition and then we'll talk about what that means. It's a map with continuous lines joining places of the same value. In other words, you're drawing you're encompassing or you're encircling an area where one is all the same. This is primarily used for weather. If you can, and when you're showing these are these lines here, the area in light yellow, for example, is encircled, it's encompassed with those lines. Those continuous lines join places with the same value. So everything in light yellow that's encompassed in that light yellow has an average annual max temperature of somewhere between 65 to 70 degrees. Or if we have this area here, these continuous lines encompass areas where the average annual max temperature is over 80 to 90 degrees. So commonly used different way to show that theme or that data using lines. The cartogram, you've seen this in my classroom. Cartograms are pretty cool. They are thematic maps where the size of the political unit, usually a country, so the size of the country, represents the amount of a particular phenomenon. These are common ways to represent population changes because so many people have a sort of an inherent misconception that the size of a place would correspond to more people when that's far from the case. So let's look at this particular one. This would be a cartogram that shows us the percentage of adults with AIDS in 2008. So the size of these political units, this particular cartogram is just by region, and the region here is sub-Saharan Africa, and you see that is the largest part of this graphic, and 22.4 million people in sub-Saharan Africa are afflicted with AIDS. And you can see that the size, then you can barely even see. I mean, you a lot of like Russia, for example, is barely even present, if at all, on this cartogram. The size of North America and South America, the size of these regions corresponds to the prevalence of that phenomenon. In this case, there would be AIDS. I want to show you this one because we're going to be working with this several times, but I want to show you another example of some cool cartograms, a way to come up with cartograms. Here, if you you can pick your parameters on this website, and it will create a cartogram to represent that. So for example, let's pick demographics, as I just mentioned, and population. And if we're just picking this here, here's a cartogram based on world population. And I just love that because it just is such a clear visualization. It takes all of 30 seconds of effort to recognize here that China and India are the two most populous countries of the world, actually followed thereafter by the United States. If we pick another one here for crop resources, if where coffee is grown, to reference back to what we studied in the last flip video with the equatorial zone. The U.S. isn't even on this map. The U.S. does not even grow any coffee, though we're one of the largest consumers of coffee in the world. So this is a cartogram. The size of the particular place is represented on the map by the prevalence. So here I just clicked on crude steel. Clearly China has massive, massive production of steel. Japan, which is an interesting statistic given that Japan is an island nation here with limited space. So anyway, cartograms can be a really great way to show a theme and to really highlight visually the prevalence or the absence of a particular thing. So let's talk about now, so these are the types of maps. So how do we make those maps? We are at a STEM school. I am hoping that one of you will make a career out of this modern map making because it is the technology that is now needed for virtually any business decision is often rooted in these creating modern maps to understand where things are and where they are not. So how do we do it in modern day? How do we make all those maps we just talked about? I mentioned in the last flip video, maritime sailors and traders used to be a big component of map making and cartography. Well, in modern day, most of that's done with geospatial technology. And most of that geospatial technology is going to fall into a general category, and that category is called remote sensing. And remote sensing is the term used to describe remote sensing being on the left-hand side now. The method of collecting data or information through the use of instruments, more specifically satellites, that are physically distant from the area or object of study. In other words, collecting data about the Earth using satellites. So you can use it when you are not physically on the Earth. You're at a distance, but you're collecting information. If you've ever used Google Earth, we'll use it in class, then you know remote sensing because if you have used the map feature on your phone, then you're using the products of remote sensing, which is collecting images of Earth's surface. Although I need to back myself up if Street View is not the case, because Street View is collected from cars on Earth's surface. But Google Earth in general, when you're zooming in from very, very far up, that's going to be an example of remote sensing. Just a depiction of that, just some of the satellites that are at any given moment, although there are hundreds and hundreds up there, but that's just an idea of what remote sensing is all about. There are two major there's two major other branches that contribute to our modern geospatial technology. But the big one that we're going to focus on and that you are going to engage in class very consistently and very regularly is known as GIS technology, Geographic Information Systems, GIS. What these are computer systems that capture, store, analyze, and display geographic information in computerized, layered maps. Please underline, highlight, bold, star, whatever you need to do, the word layered. GIS maps are maps that you see every day. In other words, they are maps that take information and layer it on top of one another. So for example, let's say that you were trying to create a map. Here's an example again just of the layers. I want you to consider this like if you wanted to know how many voters in DC, where the voters lived, their average ages, and their average income. Well, those three factors. Just forget these layers as they're labeled right now. Let's say you need to know where those voters are or who they are. You need to know where they live. You need a map of DC. You need a map of the median income, and then you're going to put all of those layers together to create those same exact kind of maps I've been showing you. Here's a map of the U.S. with the layered information on top, with shown by graduated symbols. Layer of the US, layer of the charter schools. And I actually don't even know what the blue layer corresponds to, so I'll have to go back and look that up. If you're looking here for the GDP per capita map, we have the layer of the world, and then we have the layer on top of it of where the GDP is distributed globally. So GIS is all about creating layers of data on top of one another to create accurate and relevant maps. And this is a very, very important component. I mean, just about anything. There's a whole branch of the DC government that's dedicated to creating these maps, and hopefully we're going to work with them this year to do so. For businesses that come in, I want to know where the average customer who makes this amount of money lives and what other businesses are like mine in this neighborhood of DC. And I want to know that for 2010, right? Those are four layers, things that you just put together in order to decide whether your business has a place or whether things have changed since 2010. GIS is a really, really, really important field and one that's growing rapidly. That's in contrast, this is one you're probably more familiar with than the data collection and map making that comes out of GPS. Actually, I don't want to use confusing terminology. GPS doesn't create maps. The GIS is the creation of the maps. But you're likely to be most familiar and probably have used GPS. So GPS is the global positioning systems, or the satellite navigation systems. And these satellite navigation systems calculate the precise location on Earth's surface using triangulation. Triangulation is when we use those math skills. Every time you hear that, why do we need to know this? It's all very simplistic math here in the sense of you got three satellites and you need to calculate the point of intersection, and that's your point on Earth's surface. And GPSs are now extraordinarily widespread and ubiquitous. Ubiquitous means widespread, so I just repeated myself. Um, all over, and they're now a key component of modern geographic study. Okay, here are your four analysis questions. It's extremely important, again, that you label your analysis questions with the same title as you did your notes themselves. You do need to go to that same website that I mentioned. You can either type in this hyperlink, or this URL, excuse me, or alternatively, I have posted this link on Edmodo. All right, we will wrap it up here. That's the end of this essential question, and we'll move forward into our discussions of what it means to be a geographer.